Okay, so think about this for a second. What is the hiss on an old vinyl record, a buffering Wi Fi signal, and get this, a cutting edge brain scan all have in common? It sounds kind of random, right? Well, it turns out they're all part of the same universal story. It's this constant battle between the information we want and all the random chaos that gets in the way. Today, we're going to pull back the curtain on this fundamental struggle, the signal versus the noise. So at the very heart of all this is a concept called the signal-to-noise ratio, or just SNR for short. And, this quote from the audio experts at iZotope just nails it. SNR isn't just some super technical term for engineers. Nope. It's this pivotal, fundamental measure of clarity. It's how we actually put a number on that balance between the good stuff, the useful information, and all that random static that's trying to drown it out. Which brings us back to our big question, right? What on earth connects that familiar hiss from a record player to the most advanced brain imaging that science has today? Well, the answer? It all comes down to understanding and mastering this one crucial idea, the signal-to-noise ratio. All right, so let's get into the fundamentals here. What exactly is the signal, and what do we mean by noise? The basic idea you'll see is actually pretty simple. The best way to think about it is like trying to have a conversation in a crowded room. A high signal-to-noise ratio, that's when your friend is speaking clearly, and the background chatter is just a low hum. The signal, their voice, is strong, and the message comes through perfectly. But a low SNR, well, that's like trying to have that same conversation right next to the stage at a loud concert. The noise just completely overwhelms the signal, and the message gets totally garbled. Unreliable? Basically useless. Okay, so where does all this noise even come from? Well, every single electronic system, and I mean every system, has what's called a noise floor. Think of it as this constant underlying hum or hiss that the equipment makes just by being turned on. It's kind of like the sound of silence in the electronic world. And for our signal to be heard at all, it has to be loud enough to rise above that floor. And that, of course, brings us to the signal side of the equation. We're looking for what's called the nominal level. This is the absolute sweet spot. It's the perfect strength for our signal. Powerful enough to be way, way above that noise floor, but not so powerful that it overloads everything and starts to distort. And that gap, that distance between the ideal signal and the background noise, that is your signal-to-noise ratio. Okay, that's enough theory for now, because this isn't just some abstract concept for a textbook, right? This stuff affects the technology you use every single day, a lot of times without you even realizing it. I mean, we've all been there, haven't we? The video call drops right in the middle of a sentence, the movie just buffers and buffers, the website won't load, ugh. And while sure, there can be lots of reasons for that, a really common one is a bad signal-to-noise ratio in your network. Your router is literally struggling to hear the signal through all the noise. And this really shows you how much our need for speed has raised the stakes. A good way to think about these modulation standards, QPSK, 256QAM, is to see them as increasingly complex languages. Older tech, like 802.11b, used a really simple language. It was easy to understand even with some background noise. But to get the crazy fast speeds of modern Wi-Fi or 5G, our devices have to speak an incredibly complicated language. And to understand that language without making a single mistake, the signal has to be exceptionally clean. It needs a really high SNR, like 35 decibels or even more. So what's causing all this interference, all this noise? A lot of the time, the culprits are actual physical problems, maybe even right in your own home. We're talking about stuff like poor cable shielding or old cracked cables that have been sitting out in the sun. It could be water getting into an outdoor connector, or even something as simple as using too many cable splitters. Every single one of these things can chip away at your signal, add more noise, and just bring your whole network to a grinding halt. All right, let's take this idea and shift gears completely. We're going from your home network to the absolute frontiers of science inside the human brain. Because here, the search for a clean signal, it's not about convenience anymore. It's about making fundamental discoveries about who we are. This number right here, it's just incredible. When a neuroscientist uses an fMRI machine to see which parts of the brain are lighting up, the actual signal they're trying to detect is tiny. I mean, it's just a 1 to 2% change. Everything else, that's just background noise from the body and the machine itself. The signal they're looking for, it's like trying to hear a whisper in the middle of a hurricane.
And this is exactly what that challenge looks like in the data. What you're seeing in these graphs is basically a cliff. On one side, if you have a high enough SNR, scientists can reliably pick up on that tiny little signal of brain activity. But as the noise gets louder, look what happens. Their ability to detect it just plummets. You fall off the cliff. Below a certain point, that whisper is just completely lost in the storm, and the entire experiment could be a total failure.
And this is the payoff. Just look at the difference here. On the left, you've got a raw brain scan with a low SNR. It's just a fuzzy, unclear mess, right? It's pretty much impossible to tell what's going on. But then look at the right. After they use advanced processing to clean it up and boost the SNR, boom, suddenly the areas of brain activity just pop right out. You get clarity from the chaos. This is literally what allows scientists to make these incredible discoveries. Okay, so far, we've been treating noise like it's just a problem to be solved, right? Something you can fix with better cables or some clever software. But what if noise is something much more fundamental? What if it's actually baked into the very fabric of reality itself? Well, this quote right here takes us to the very, very edge of physics. It turns out that at the quantum level, the universe is this fizzing, fluctuating sea of energy. And those tiny fluctuations, as these researchers put it, they create inevitable noises. Think about that. It's not a flaw in our equipment. It's a fundamental feature of the universe. So let's just put that in plain English for a second. That ultimate background hiss that we're always fighting against, it's not just coming from your amplifier or your router, it's coming from reality itself. There is a baseline of cosmic static that we can never, ever get away from. And the implication of that is, well, it's profound. It means that because of this fundamental quantum noise, there is an absolute physical limit, a cosmic speed limit, if you will, on how clear any signal can ever possibly be. There's a ceiling on clarity. We can get closer and closer to it, sure, but we can never, ever have a perfectly noiseless signal. It's impossible. Okay, so let's bring this all back together. We've gone on quite a journey here, and we've seen how this one single concept connects our everyday lives to the very laws of the universe. Think about it, from a crackling guitar amp to a dropped Wi-Fi call, all the way to peering inside a living brain and even to the very edge of physics. The challenge is always the same. Whether you're an audio engineer trying to get a perfect mix, a network tech trying to fix your internet, a neuroscientist mapping the brain, or a physicist probing the nature of reality, you are all fighting the exact same battle. It's the universal struggle to pull a meaningful signal out of the overwhelming, ever-present noise. And that really just leaves us with one final big question to think about. We've gotten so much better at filtering out noise to find the signals we're looking for, right? But in a universe that we now know is fundamentally, inescapably noisy, what profound signals are still out there, just beyond the edge of our perception, waiting for us to figure out a new way to listen?